Hello, in this video I want to talk about the differentiation of products, otherwise known as the products rule. Without working it all that explicitly, we can say in general that if we have f of x and that equals uv, where u and v are both functions of x, then f prime, and that is in prime notation, that is, f prime of x is going to equal uv prime. And if you work this out, what you end up getting is uv prime plus vu prime. And this is the product rule. And it's probably one of the earliest examples that one will be will be introduced to one when it comes to how to differentiate more complicated functions. In this case, we're dealing with the product of two functions, right? Where f of x equals the product of two functions, u and v. And it's probably best to elucidate all of this if we just look at an example. So let's just say we're asked to find the derivative, or we need to find the derivative of something like f of x equals x cubed sine x. Now the important point I would say, and this relates to my previous video on the chain rule, is that when developing an eye when it comes to evaluating functions, it's important to not confuse the product of two functions with the composite function, right? Because a composite function is going to look in general something like f of g of x, something along these lines, right? Whereas the product of two functions is well, in this case it's actually quite basic and explicit, which is nice. We just have x cubed, right, which is one function, and we have sine of x, which is our second function. And it's actually in cases where the function that we're evaluating and analyzing is much more complicated, you can mix it up. You have to be very careful, where maybe one might be inclined, if you have a composite function, to take the products or something. I think that's a common mistake. In this case, we can see quite explicitly that the product of two functions here, f of x, is x cubed sine x, and we can separate the two functions. However, having said that, we could very well, this is kind of, the separation is a little bit arbitrary, in the sense that we could say, if we say, for example, that this is u, whoops, it's a bit messy, let's just say this is u, and let's just say sine x is our function v, right, uv. We could alternatively say, we could say something like u equals x squared and v equals x sine of x, right? I mean, this is a very simple example, but if you multiply u times v, you're going to get x cubed sine x, right? It's the same result in the end, and the same product, I should say. And so it's a little bit arbitrary in how we separate this, how we separate the two functions when using the product rule. At the same time, I wouldn't stress its arbitrariness, because really what one wants to do, and this is the underlying logic, and I'm not sure this is always pointed out, but we're really using inspection when taking and finding the derivative of a product of two functions, right? We're using inspection insofar that we're just saying, okay, how do I separate these two functions in a way that either leads me directly to a standard result when differentiating them, or to something that's very simple to differentiate, right? Like if we separate u as our x squared and v as our x sine of x, when we use the product rule as written up here, right, it's a little bit more messy to apply it to with this separation, as opposed to the separation where u is just x cubed and sine is x. And so what I'm saying is that there are alternative ways to separate the functions. In fact, there are many other alternative ways than what I've just written here. But the key is, in like a lot of calculus, I would say, is to use inspection and to rely on standard results as much as possible, really, in the simple cases at least. So So in this case, let's just carry on. You know, we need to find the derivative of f of x here. It's the product of two functions, and we say, okay, well, f prime of x then, to use prime notation, is going to equal, well, what's u? Well, right, u times v prime is our first, and then we have plus v times u prime. So what is u? Well, we know u is x cubed, so we just go like this, x cubed, right? What's v? V primed, well, the v is sine of x. Well, if you take the derivative of sine of x, you're going to get cos x, right? So that's why we just write cos x, and that's what I mean by separating the variables in a way where that would lead to either standard results or to just very easily differentiable functions. And that's exactly what we've done here by just making u x cubed and v sine of x. And so we just go plus, we've got our v, well, we already know that is sine x, don't we, right? So we just go sine of x. And then we've got our u prime. So what's the derivative of x cubed? Well, again, that's very easy to differentiate. It's just going to be 3x squared. And at this point, we've already used the product rule, so we're pretty much done. We just need to clean up algebra a little bit. So let's just write, it's going to equal x cubed cos x plus 3x squared sine x. So the biggest piece of advice I would say is definitely watch so as not to confuse the product rule with the chain rule. It can be tricky with some functions, certainly. One might have a composite function in the form of f, something like this, f of g of x, and you might say, okay, yeah, I'll just take the product rule because it looks like, well, maybe it's the product, but it's not. So I would just stress that for sure. And also, when it comes to evaluating your function, how to maybe separate it, to use the product rule is really to use it by inspection and to try to separate the two functions so you get a standard result, if at all possible, or at least to two functions that are more easily differentiable.